Hello, my name is Uwe Artmann. I'm CTO of Image Engineering. IEEE-P2020 is the standard for image quality in automotive systems. It's the first international standard in this topic. So how can it help you? Let's have a look at that. Let's have a look at flicker. So when we say flicker, these are the effects that I typically talk about. So for example, you see there on the left there's a road sign, these 80 kilometers per hour. For a couple of frames, it's invisible to the camera because the camera has a problem with the PWM that this road sign has. Also, in the scene that you see in the top right, that is something of an annoyance because these road lights, they also use PWM, so that causes a general flickering effect on the entire image that you capture. And that's at least an annoyance, if not really a disturbance for the detection algorithm. You see these videos in the lower part where you have these different artifacts. That is actually the Vega light source creating different kind of frequency or duty cycles and phase, and that can cause then quite different artifacts in the image. So with these light sources you can create these and really check if like flicker mitigation in the sensor does actually work. In P2020 there is the metric of MMP for that. MMP is based on the observation of a certain area in the image. So let's assume, or let's observe a single pixel over time. And if you have some flicker in the image, it will change the intensity to a high and to a low value. Or if you have some bands going through the scene because of flickering artifacts, that will also cause that this pixel will get brighter and darker over time. So that gives us, if we have this flicker, that gives us two distributions in the over time, which we can then observe. So now we can use the same approach as we use for CTA. We calculate the probability that a certain value falls inside this distribution or that it's outside. So you see that down there. If the flicker mitigation is on, all values are just with some temporal noise, but they stay very much at the same level, so that all falls into a certain bounds. So that means there is no flicker in the image. As soon as we have flicker, so the flicker mitigation is turned off, we will get two distributions. So that means that a lot of these values fall outside of the mean value, so of the area that I would expect. So I get a low MMP. How does that look like? Again, we create a map. So yellow means low flicker, blue is high flicker in the scene. So now on the x-axis, we state again the luminance at which this was measured. And then on the y-axis is the frequency at which it was tested. For the test itself, the test now here is then defined for one specific duty cycle. So here for 10% duty cycle. And what is important for the capture process, we also change the phase. So you can imagine you have a camera that is capturing constantly an image, and you have a flickering light source. Depending how they work to each other in terms of timing, they can create flicker or no flicker, so it depends on the phase how they are time-wise next to each other. So that's why we need to scan through the entire phase, and that's what we can do with the Vega light source with the VLS setup, so to get into these maps. So now here is an example. So get that on the left is the MMP for 10% duty cycle, on the right is the for 90% duty cycle. So what is interesting to see here then on the left, so that's for the different color channels of the sensor. So what you can see is that the flicker depends on the intensity. So depending on the intensity, you have flicker or you do not have certain flicker artifacts. And that's quite obvious, but that's not what all tests do. So many tests for flicker do not change the intensity. So here this is done, and this is very important because you see, depending where you are in the region, you have flicker depending on the intensity. But also for the frequency, it's quite interesting. So you see here, for example, at 100 Hertz, flicker is perfectly mitigated, at 200 as well. But in between, you already, again, have strong flicker. So that if your sensor has flicker mitigation, it is obvious that this flicker mitigation works well for a certain frequency, but not for all frequencies. And that's very important to check and to see.